Thank you, everyone. Thank you for coming, everyone. I wasn't expecting this much interest in the topic, so I'm really happy to see that. I think many of us have observed how gluten-free, wheat-free has become a pretty dominant theme when you're out shopping. Even mass market chains now carry quite a few gluten-free options. There's been a lot of celebrity attention even. I know that Dr. Oz's daughter, Daphne, for instance, wrote a really well-known book that was featured on Oprah on how she helped relieve a lot of health problems in college just by going wheat-free. There's an MD out there that wrote a book called Wheat Belly, which is getting a lot of attention right now. And it's a very interesting phenomena. I'm from the health food industry, so when it was low carb that was the fad, it did quite a lot actually for the growth of our sector. And then it just petered out. A lot of bad things happened with that diet, which aren't necessarily unrelated to this talk, because the Atkins diet was largely grain-free as well. And that's one of the reasons why I attribute great success to it, because it was implicitly wheat-free, as is the South Beach and the Hampton diet and the paleo diet. So what I find so interesting is that the sort of theoretical context is really missing. Like, people know they feel better. I've observed it personally. I've recommended this gluten-free diet to hundreds of people, including family and friends, who are more reluctant to take my advice. The more closer they are to you, they are more resistant. But I've observed quite amazing things happen. I personally had quite a lot of issues that were associated with really classical celiac, which is gastrointestinal disturbances. So, the original presentation since ancient times, because it was first observed in Greece, ancient Greece, was diarrhea, malodorous stools. Sometimes it's called steatorrhea. The fats just don't digest and they putrefy. Subsequent lack of absorption of nutrients, like malabsorption, bloating. Sometimes you'd have loss of weight, pretty severe, from inability to absorb anything, because what happens with celiac disease proper, the classical medically defined celiac disease, is that you see a autoimmune destruction of the villi lining the intestine. The villi are these little, it's like almost like beds of seaweed, just billions and billions of these little projectiles coming off the cells of the intestinal wall, the enterocytes. And without those projections, which have profound amount of surface area, I believe that if you were to spread across a two-dimensional plane the surface area in our intestines, it's about the size of a tennis court, which is also why humans are very prone to obesity and weight problems, because we were designed to live through a lot of famine times, which is another thing we'll be talking about during this discussion. But intestinal issues, classically defined, you get a biopsy, that's the gold standard. If you see complete flattening of the villi, and then the crypts in between, like are these little valleys in between the little mountains, are also filled in with tissue. It's called hyperplasia. The tissue just grows, not serving a function. And it's not really cancer, but it could be considered similar pathology. And so that's classical celiac, and it was once believed to be extremely rare, only afflicted Europeans, maybe 1 in every 10,000 people. And today, a huge body of research indicates that it is not actually that rare, and present figures are between about 1 in every 100, and now some are saying that maybe 1 in every 60 have classically defined celiac disease. So if they were to do a biopsy, they would discover it. The problem is the conventional medical community doesn't really know enough about it, not really trained to look at the connection between diet and illness. You have epidemic level disorders pop out of the void, like irritable bowel syndrome. And I'm not saying that wheat is the only cause of that symptom picture, but it's a really significant cause. And the medical literature, thankfully, is now vindicating that awareness. So, one of the things that I have up here is a PDF ebook I produced, which just covers 2 main essays I wrote on the topic, which also includes a quick reference guide to the National Library of Medicine's database on wheat-associated diseases. There's over 120 of them, and we'll kind of look at them real quick to see just how big a problem it is, even in the medical literature. So it's no longer really, what I want to do with this discussion is to shift the focus from what you might call the victim, which is the extremely rare case of a genetically determined intolerance to wheat. And I want to also kind of shift the debate away from this concept of wheat sensitivity and intolerance, as if somehow it's the perfect food and we're just not strong enough or not biologically capable enough to consume it in a way that's healthy for us. That's really what I'm trying to do, is look at the deeper levels to the problem. Before I go further, I should just say I'm available, for goodness sake, in Bonita Springs. It's a store that I've managed for about 10 years now, and I do their education. And we really like to focus on just providing information. The sales will come, but it's not really a big push of ours. We don't even advertise, for instance. We do like to do these sorts of free lectures, though. And then I do writing for different journals. I'm in the latest well-being journal on the topic of breast cancer. And then my website, Greenman Info, houses a lot of the research you're going to be hearing about today. I also provide a lot of support to Mercola.com, who is, Dr. Mercola wrote a book called The No Grain Diet. So, before I knew that, I was kind of just immersed in the research myself. It's so compelling. When you really look at the paleo diet and the idea that our bodies have evolved for millions of years on a specific diet that changed radically just about 10,000 years ago. Now that sounds like a lot of time. It's a nanosecond in biological time. Cultural time, it seems like forever. It is forever. So that's going to be also one of the things we talk about. So the two essays are available to view for free on my site, of course, and all the research I'll be discussing. There's no limitation there. Some of the broader strokes are weight gain. I'd like to really go more into detail, but when you look at the essays, you'll see there's such a volume of research, so I will be jumping around here and there. Weight gain is a big part of the problem. Now, although you have the autoimmune variety, again, relatively still marginalized, the celiac disease sufferer, they tend to lose weight. They can absorb anything. But then you have the other side of the spectrum, which is, why do they give wheat to animals before they slaughter them? They give it to them so they gain weight rapidly. And these are the animals that were designed to consume the grasses in sprouted form, not the seeds. And that would be your, the beef that we eat, almost every day here as Americans. So they give them the seed form later in their life cycle to put weight on quickly. Now, if they do it too early, they end up killing the animals. They end up developing acidosis, tissue pH gets really acidic. They end up getting abscesses in their liver, and then they have to give them antibiotics. It's really quite a nightmare. And these are the animals that spent thousands and thousands of years of just eating grass. But they can't handle a certain amount of the seed form. They actually develop a lot of degenerative conditions that are kind of linked to what you would call the diseases of affluence associated with the Western world. The grain-based model of being human. So weight gain is actually part of the picture, and in fact there are very specific mechanisms that have been identified. Wheat contains a specific substance called wheat lectin, which is insulin mimicking. It's called insulin mimetic. So it really just sends a signal to certain cells in your body: take sugar, turn it into fat. Okay, not to be burned as energy, but to store it. So that's one reason why when people remove wheat from their diet, within a week you start seeing weight loss. I mean, pretty significant. And it's often around the midsection, which is pretty characteristic of what they call hyperinsulinemia, where insulin goes too high and there's this constant signal to the cells: store fat. It's a lot of times in the midsection. And this is really the characteristic modern disease for Americans. It's known as metabolic syndrome. Midsection fat, elevated blood lipids, elevated blood sugar, elevated insulin, hypertension, chronic inflammation. That's a constellation of symptoms and or diseases they call metabolic syndrome. Well, wheat is actually one of those foods that I believe plays a pretty key portion of the problem. One of the most interesting things of all is that we are a society that, when it comes to supplements, spends close to $1 billion a year on eating the exoskeleton, okay, of sea bugs, insects literally, like sea insects, like crabs and lobster and shrimp. Those pulverized shells are put into capsules and sold to you as glucosamine. And so that's really what people are eating. Now, I don't personally have a problem with that. I mean, I don't think it's really bad, you know, because they're bottom feeders or whatever. But why do we do that? Okay, is osteoarthritis, which is what it's used for, caused by a lack of pulverized shells from sea creatures? No, it isn't. But it's really effective. And some people claim, especially when they stop taking glucosamine, that their inflammation really starts to recede. Or when they stop taking it, they see it flare up. You know, because we're an anti-inflammatory addicted culture, right? Our NSAIDs we can't live without. We need our aspirin, our Tylenol, ibuprofen, our aspirin, our Vioxx, which again was ripped off the market because it was, you know, inducing heart attacks. Those anti-inflammatories are very dangerous. So I'd rather see people use glucosamine, of course, under the guidance of a physician. Check with your physician and make sure it doesn't interact with your medications. The point is this, is that wheat contains a specific, what's called lectin. Lectins are the invisible thorns of the plant kingdom, okay, because they don't have the horns of a rhinoceros, they don't have claws, they look kind of helpless, we want to eat them, they taste good when you make pasta and bread from them, but you know what? They were designed to defend themselves from predation. So wheat, technically, contains this little invisible thorn that's been identified as wheat germ agglutinin, WGA it's called, and it selects for just two things in the body, one of which, okay, just so you know, lectin comes from the word origin, select. Okay, very specific. It only attaches to two biomolecules in nature, and there's millions of them. One of them is sialic acid. What is sialic acid? Well, it's this mucousy, slippery surface that coats our nasal passages and our whole gastrointestinal tract. It even coats our blood vessels and arteries. And that slick substance protects us really from a lot of what they call antigens or things in our diet that we shouldn't be eating. So you eat something, you get all this mucus that forms, it's almost like having a cold. And your body's kind of telling you, don't eat that. It could be cow's milk products, it could be sugar, it could be something that your body just doesn't want it in. Well, wheat lectin was designed by nature to select for that specific substance. That substance is integral to all the natural predators of wheat, from fungi to bacteria, to worms, insects, birds, reptiles, humans, just all the way up the food chain. So it's a very interesting fact. Now, okay, why am I saying this and talking about glucosamine? Because glucosamine is the other thing it selects for. So wheat is designed with this sort of laser-guided biomolecule that attaches just to glucosamine in your body, specifically N-acetylglucosamine. Now, N-acetylglucosamine is a building block for almost our entire body. Our epithelial tissue, you know, like the cells that line the intestinal wall, our cartilage, our connective tissue, and our neural tissue. So it even attaches to neural tissue or interacts with neurological cells, which will be interesting when you look at the research on neuropathy, schizophrenia, and autism, and all the other connections. So my thing is this, if you're taking glucosamine, or if you take a synthetic chemical like ibuprofen to relieve your pain and inflammation, sometimes if you remove the wheat, the inflammation just disappears because the cause has been removed. Otherwise, we're doing more of a palliative medicine. If you take a couple grams of glucosamine a day, split it out throughout your day, instead of the wheat lectin attaching to your intestinal membranes and getting into systemic circulation, which is the real problem, it'll attach to the dead bodies of the little sea bugs. I mean, it's pretty interesting. It's called chitin. I mean, insects are made of it too. So these long polymers of N-acetylglucosamine. So that's kind of one of the interesting things about wheat lectin. So inflammation, big part of what wheat does. And inflammation is behind so many diseases. I mean, all the chronic degenerative ones that afflict us, from osteoarthritis, cancer, diabetes, osteoporosis. Inflammation is key. Okay, you have issues like depression. Well, depression is psychospiritual as well as physical, so I'm not negating certain causes that are not just physical. However, we do know that wheat contains a broad spectrum of proteins. There's actually 23,000 different proteins in wheat. Actually 23,700 and something that have been identified this far. So when people talk about wheat or gluten intolerance, they're just talking about really this broad concept of there's a protein that's harmful in wheat. And there's just so many. And the reason is that wheat is the first truly genetically modified organism. that we created through selective breeding. So we didn't take recombinant DNA technology and alter its structure the way they do today with GMOs, but we bred it in such a way that 3 distinct plants became one. Okay, that's called a hexaploid species. So basically, it has three sets of DNA inherited through its 3 different predecessors, and it's capable of producing. Actually, it has 6.5 times more genes than we do. We consider ourselves so complex, and really, we're not. In fact, this is going to be really important when we talk about why celiac disease isn't caused by the genes, which is really important for people to understand. So, I know a lot of this is kind of over people's heads, even my own, honestly, but I'll try to keep it more grounded if I can. Now, constipation. I mean, people are eating wheat glue, okay, because gluten is the Latin word for glue. You take wheat paste, or just basically flour, and you add water, and you add some newspaper, and you have pretty much concrete when it dries. You know? I mean, we love eating glue, and it's considered normal, whereas freaks like me who are like, considered, food fascists by their friends because I don't want to eat wheat, and I don't eat wheat, people really look at me as a freak, but I'm not. I feel like, how can you eat something that would be impossible to break down? Here's the problem, is that we are monogastric, one stomach. If you look at the ruminant animals, like cows or goats, that have been designed to consume grasses for a very long time, they have a 4-chamber forestomach, and they basically ferment and break down that protein complex, which is basically disulfide-bound protein. Now, disulfide bonds are what you find in rubber. I mean, you vulcanize rubber with sulfur just to make it even more rubbery and indigestible. Your hair, when you burn it, smells kind of weird, sulfurous, because there's sulfur in it. You can't digest your hair. Well, that's what gluten in large part is made of, is disulfide bound. And humans were not designed to consume this type of food without doing things to it. I mean, you can cook it, you can try to break it down. You could do sourdough, which is really quite intelligent, because you're trying to break down all of these sticky proteins. Now, when you don't break proteins down and they putrefy in your gut, it leads to quite a lot of problems. Gastritis, acid reflux, there's all these different words to describe what happens when wheat sits there and other opportunistic organisms come in and try to break it down for you. Many of them, when you ferment protein, produce hydrogen sulfide, which is extremely irritating gas. It's, I think, more deadly than certain types of cyanide gases. Now, in small amounts, it's essential for the health of our gastrointestinal tract. But when it gets to elevated levels, and people on proton pump inhibitors and acid blockers know what happens, I mean, sometimes it makes it far worse because you just made it impossible to break protein down. You need acid to do that. So a lot of people who get diagnosed with acid reflux or GERD, or they do the scope and they see the inflammation, it's really caused in part by the putrefaction of these sorts of proteins, is my understanding of it. So that's what we did to get around, is we tried to culture things, we tried to break it down, but unfortunately, when it comes to many of these proteins, it cannot be done. Even high heat, you can't break down wheat germ agglutinin or wheat lectin, it's known as. It's just impossible. So let's see. Okay. So this is, again, a downloadable PDF on my site, but you can read the articles for free and you can access the research for free. I just did it for convenience and to try to generate some type of support for the website. So yeah, that's the funny thing about wheat. Its status is exalted, both secular and religious. Okay, so for me to come here and tell you that wheat somehow is not healthy sounds heretical, and it is. Because, that's the Eucharist, right? That's the body of Christ. And for quite some time, as they began to recognize, the Catholic Church, that celiac disease was more common than previously believed and a serious, serious threat to health, even deadly, they started to make room for wheat-free version, but they held on for a very long time, and many places still only do wheat because that's considered a necessary spiritual food. Okay, and interestingly enough, if you buy Ezekiel 4:9, and this company probably dislikes me passionately because I even called their nutritionist to discuss an article I wrote because I was trying to expose the fact that the poster child of the health food industry, whole wheat bread, and especially sprouted Ezekiel 4:9, it's biblical, it sounds sacred even, isn't really using the type of wheat that Jesus ate or any of his contemporaries, because that was not the kind that we're talking about today. Today it's really common bread wheat. It's called a Triticum aestivicum. I think I'm mispronouncing it, but we'll get into that in a minute. Now, the United Nations has an agency that is dedicated to just getting rid of global hunger, and it's called the Food and Agricultural Organization, and its emblem is the Latin motto, "Let there be bread." Okay, so as you can see, there's nothing more exalted than wanting to put an end to world hunger, you know. So, again, there's a lot of resistance to the concept that wheat is somehow harmful. In fact, it's the #1 cereal grass grown in temperate regions. There's going to be about 700 million tons of it, and this is just the seed again, produced this year. It's the third most commonly produced cereal grain in the world. So we're working against a lot of inertia when it comes to getting the awareness out. It's a globe-spanning organism, really. I mean, it's taken over so much biodiversity on the planet that one issue alone is reason to take pause when we think about elevating it to the sacred status, because when you take away your biodiversity and you do this monoculturing, you just have corn or you have soy or you have wheat, thousands of acres, you leave it open to basically locusts or plagues, or basically the plants are more susceptible. So that's one big problem, because the world now depends on wheat production, and if it fails, then a good number of us will starve on this planet. So that's another interesting aspect to why wheat isn't really as good a thing as we think it is, especially when you get into the way agribusiness works and the type of pesticides that are used, etc., and the type of forests that are destroyed just to produce more. Okay, so the basic premise here, celiac disease is living testimony to the lesser known dark side of wheat. My premise is that wheat intolerance, or the incompatibility between our species, is universal, okay? And that at one point, genetically speaking, every single human, okay, our ancestral lineage from which all of us came 60,000 years ago or beyond that, or if, again, you're more of a religious sort of fundamentalist view, the Garden of Eden, okay? There weren't even grains there. It was a fruit type of food that was presented in that document. So what happened is, over the course of the evolution of Western civilization, there were a number of die-offs, bottlenecks that literally whole groups of people passed through in quite dramatic fashion. A quick example of this is in Ireland, because Ireland was not conquered by the Roman Empire, and the Romans were actually known, their empire was known as the Wheat Empire, because largely it depended on access to and conversion of conquered peoples to the agrarian mode, basically growing, consuming, trading wheat. That was the basis of the Roman Empire. And so there were certain regions that resisted being conquered. Certain regions in Germany, Finland, Norway, and still today, the highest levels of celiac disease prevalence are found in those regions geographically. And because when they did introduce it, it probably caused dramatic die-offs in certain individuals. That celiac disease, I mean, if you really think about it, any of you here may know personally, in the part per million range, okay, we're talking about infinitesimal amount of gluten contamination can induce life-threatening autoimmune destruction of your intestinal wall. I mean, it's so sad when you meet people who are afflicted with this. I mean, I talk at the celiac societies where it's just people who are just threatened by anything, because they can ask their waiter not to, it does have wheat in it, and there's always some type of byproduct from wheat that's contaminating your food. So it's very hard to live with that. But that's how serious the problem is. It's that toxic. So is it that they're just genetic freaks, and that for whatever reason they can't handle an intrinsically wholesome food? Or is it they're an extreme representation of a universal intolerance that we all participate in, and that most of us, it's really asymptomatic? We don't really see that kind of clinical presentation, or they sometimes call it out-of-intestine varieties of celiac disease. Now, how can I say that? Well, genetics really has come in recently and supports this, because 20 to 30% of the world's population has the gene for celiac disease on chromosome 6. HLA, human leukocyte antigen, DQ8 and 2. So you can go to many different races on the planet, and you can go to Africa, you can go to China, you can go to India, and you'll find the prevalence of the gene is extremely high. So that's what makes it so fascinating to me, is that it's not a rare disease. So yeah, this is just a quick view of the intestinal wall as it degenerates. Okay, and here's just some of the research that I want to show you, because it's been about 3 years of investigating this specific health problem. And I'm not satisfied just with theory. I mean, my background is a philosophy degree, and people sometimes think that that's ridiculous because, you know, this is a medical type of thing that I do with 3 Minute Info. But for me, it's just a pursuit of truth and, you know, using whatever disciplines at your disposal to figure it out. Science, anthropology, art, anything. But because of that lack of a background with science proper, you know, I decided I would embark on a very laborious project, which is go on the National Library of Medicine, and anyone can do this. It's got 21 million citations going back to 1950 and beyond from 5,000 plus peer-reviewed journals, biomedical life science journals, and you can kind of Google it. Go in there, write weed in, pick a disease of your choice, and you'll find any number of studies. Now, the way we have it organized is, obviously, celiac disease is the main one you find, and I only scratched the surface. 108 articles. Wheat intolerance, gluten sensitivity. They're all just different names for intolerance to wheat. And there's a lot of confusion, again, as to what is the right one to call it. Autoimmune diseases. The most interesting at first was schizophrenia. Because back in the 60s, they noticed when you took schizophrenics, certain of them, put them on a gluten-free diet, some of them would go into remission, or their condition would improve so dramatically that it was just so shocking to these researchers. So at least 12 studies on schizophrenia responding to a gluten-free diet. Now we should probably pause there a moment, because why is that? Well, this is probably the most interesting of all facts about wheat, is it has a number of opioid peptides, okay? Now opiates are naturally secreted by our body. In fact, women breastfeeding secrete morphine literally in their breast milk. When you have an infection, your body actually produces literal morphine. Okay? And cow's milk has casomorphin. I mean, opioids are throughout nature. If you eat meat, there's an opioid-like substance in it. If you take lettuce, I mean, it's so potent an opiate, they used to make a drug out of it. Just lettuce juice extract. So with gluten, you have a number of them. One of them is glidorphin. And it sounds kind of like endorphin because that's what you produce endogenously in your brain. That's like basically morphine. And then you have 4 to 5, depending on the source I'm reading, different glutamic sorphins they're called. And they all interact with these opioid receptors throughout the body. So what I'm saying is it's actually quite addictive. I mean, people love, I mean, they will die for a good, you know, fresh, you know, baked loaf of bread and a little butter on it. I mean, it is so, I can't resist it myself. That's why I stopped eating it, because I don't have the willpower. Certain things are just too good. I can't stop eating them. And it's because of that addictive property that also reflects in certain neurological conditions like autism and ADHD, a lot of cerebral issues, ataxia. So it has a it is basically a pharmacologically active substance. Now that's the tip of the iceberg, even with this particular part of it, because it's high in glutamic acid and aspartic acid. These are 2 excitotoxic amino acids found in nature. They make things taste good, though. So like, if you're eating something with MSG on it, you just really can't stop yourself from wanting more, because it sends signals to the hypothalamus that you're not hungry. And it's found at extremely high levels in gluten, because gluten is actually classified as a prolamine protein. Prolamines are found throughout the cereal grasses. So you have avinin in oats, you have seculin in rye, hordein in barley. They're all called design in corn. It's all prolamines. Now prolamines are lysine proline rich. And they have a lot of, they're proline glutamine rich. Okay, so glutamine and glutamic acid stimulate that receptor in your tongue, which the Japanese call umami. The taste, you know, they invented MSG from, I think it was kelp originally. So when you eat bread or something with wheat, it is an immediate taste sensation. You just want to eat it, and then a good maybe half an hour, a little bit later, the peptides start to break down, and you get that kind of food coma. That's when people normally want to have a cup of coffee or maybe smoke a cigarette, shot of whiskey or something, just to kind of stimulate themselves again. So it's a pretty common phenomenon. There's this kind of like this vicious cycle with food, and wheat, if you really observe yourself, if you're going to continue to try eating it regularly, does have those addictive properties. Let's see. I'm going to flip. There's so many things here. Actually, herpetiformis dermatitis, which is sounds like something from Harry Potter, you know, but it basically looks like you have herpes, and it's caused by wheat. It's a classically defined, very well-known wheat side effect known in dermatology. Psoriasis as well, there's a connection. What was I going to say? Diabetes type 1. I mean, so interesting. It's a diabetogenic food, at least has potential to be, because basically, you know, that's number one is when your immune cells destroy the beta cells in your pancreas, the ones that produce insulin. And there's some type of confusion that happens. It's called lack of self-tolerance. The immune system stops recognizing its own cells as being self and says, oh, that's other. Well, what they've identified is that there are proteins in wheat that are capable of activating these HLA, human leukocyte antigen, what are they called? They're like carbohydrate projections off the surface of the cell. And that's like a red flag saying, hey, immune system, attack me, I'm different now. So that's what's so fascinating about food, is that there's a whole field known as nutrigenomics that looks just at the interaction between nutrients and your genes. And there's a direct interaction. It's not necessarily immune mediated either, meaning you don't have to be classically defined with an autoimmune condition to be damaged by wheat. The wheat actually attaches to the healthy cell surface, changes the way that it looks to the immune system, and then the immune system comes and attacks it. Whereas the former view is really, it's just the immune system, for whatever reason, doesn't know what it's doing, just attacks the body, from, you know, really without any logic. So there's okay. So I know it's kind of going all over the place, so I try to bring it back down in terms of understanding this. Basically, my argument is that you don't have to have an immune-mediated problem with wheat, that the wheat directly adversely affects the cells in our body. And it doesn't require that you go in and get a test for celiac or an antibody test, because that's really what they do, is they look for anti-gliadin antibodies, which is one of the main proteins in wheat associated with the problem, or endomycin. There's a number of them that they look at. Even if you have no antibodies, no visible clinical sign that you have intolerance, I believe that you are, and that our bodies are adversely affected by it. Now, sometimes it's better to just throw all this jargon and all these concepts away and just try it, because that's really what I've seen, and that's what encouraged me to do all the research, is I saw how profoundly it adversely affected people. Yes, ma'am?
Are you talking about development of leaky gut syndrome?
Yeah, that's one of the things. See, there's something that happens when gliadin, okay, is one of the many proteins in gluten, okay, because gluten, again, is this big category. It's alcohol-soluble, and the form that causes celiac, okay, is alpha-gliadin. That substance has been shown to upregulate a protein in the intestinal wall called zonulin, which then basically opens up these gaps between the enterocytes, the little intestinal cells that line our entire gastrointestinal tract, right? Basically what happens then, it causes intestinal permeability. And this happens in people that have no celiac disease, no genetic predisposition. It's a universal problem. And what happens after you open up the intestinal wall, even just slightly, is that contents naturally within your stomach enter the bloodstream, and then any one of those 23,700 proteins could enter the blood and then cause the immune system to say, oh my gosh, what is this? Is this self or other? I'm just going to start attacking. And that's really one of the big problems. I call that opening Pandora's bread box, which is my second essay in the series, because it really looks at the way in which wheat, by its very design, okay, it's very similar to viruses. Wheat lectin, about the size of a virus on some level, attaches directly to the slippery protective mucus coat, and then it causes a breakdown of that protection, and then enters through inside, causing basic permeability. Afterwards, all the other proteins have much easier entry into the body. Now, here's a way to look at it, okay? Celiac disease or wheat intolerance is like a gun, right? It's sort of a genetic gun. It could go off. The bullets are the wheat, but without a trigger, it isn't necessarily going to express itself acutely or in any kind of obvious way. It takes an event. It could be an intestinal infection. That's what's so fascinating about this is that, okay, H1N1, hemagglutinin type 1, it's like a little claw on the virus that attaches to the surface of the cells. It could be in the nasal patches, wherever. And then you have neuraminidase type 1. That's what H1N1 is. And that enzyme, neuraminidase, is exactly what wheat lectin attaches to, sialic acid. So there's a very similar nature between viruses and lectins. And that's why they say starve or fever, is that if you end up contracting influenza, and then you have this breakdown, or basically the virus is trying to get through that sticky coat into systemic circulation, that's when you don't eat, because the lectins then cause the problem to be far larger. And all these foods you've been eating for so long, it could be nightshades, it could be wheat, it could be cow's milk, suddenly become a big problem. And then that establishes later an autoimmune problem. And it's sustained by these food antigens or lectins. So it explains why some people have eaten wheat their whole life. Some event occurs. It could even be stress. Acute stress will deplete you of glutamine, which is the primary fuel source for the intestinal cells. And it could also cause permeability, even within a matter of days, because in 2 days, your intestinal cells regenerate. So you have to give continual support nutritionally to those cells. So that's what's, there's complexity here, of course. So the trigger that makes that gun go off is something as simple as a stressful event, chemical exposure. It could be a virus or a bacteria that suddenly takes over you until it's gone again. So yeah, intestinal permeability is a big part of the problem. And that's something that, like if you ever had, I think it's called a LCAT, or it's a LISA, it's an antibody panel. They look at maybe 300-400 different foods in your diet and you can see, wow, I'm producing antibodies to cheese. Well, it's obvious. My immune system thinks it's the enemy. That could be why I'm not feeling good. And you'll see these people do the tests, and they'll have 50 or 100 different things that the immune system apparently is just kind of upset that are in your body. Well, that's because the Pandora's box was open. The intestinal permeability is causing constant influx of undigested proteins. This is a real fascinating fact about wheat. Because there's so many proteins to select from, there's one called 33-mer. It's an abbreviation for 33 amino acids long. And because it's not broken down, right, you want to break those amino acids down so you can reconstitute them as protein in your own body. So instead, because of intestinal permeability, they go into the blood. Well, that particular very virulent protein has the exact same molecular sequence as protactin, which is the primary toxic substance in whooping cough pathogen, which is called pertussis. They even take protactin and put it in vaccines just because it jacks the immune response up and causes all kinds of increased antibody titers, which isn't necessarily healthy. That's one of my big criticisms of vaccines, is it doesn't mean that the antibody has affinity to the antigen. It just means you threw the chemical sink into the tissue to try to startle the immune system. It's like kicking a beehive. So that's the fascinating thing about wheat, is it's got this protactin-like protein, and it's only one of 23,000. So I can only imagine the types of confusion it causes in the body, especially since we weren't designed to consume it from day one. It was something that, this is going to help you all understand. Okay, after going through, there's 129 diseases here, and you can keep going down. They're all on my site. And 16 different identified pharmacological actions that are adverse, like their neurotoxicity. Teratogenic is actually because of birth defects and miscarriages. That's a big issue with recurrent miscarriages. Immunotoxic, immunoreactive, proliferative, because it can cause this hyperproliferation of the intestinal cell wall. Cardiotoxic, I mean, this is such an interesting topic. We can talk about that later. Diabetogenic, goes on and on. And again, I'm not even close to being finished. There's thousands of more studies to look at on this topic. Yeah, let's see.
How do you know the studies you're reading are valid studies, though? A lot of times the number in the study is small, and so that is a problem with a lot of studies, and a lot of times they're short rather than extended.
Yeah.
So how can you evaluate whether or not these articles that you're saying that there are 80 of or 3 of or whatever are actually valid research projects?
Well, because I don't really think there's like a powerful wheat lobby. It's not like with drug companies, for example. It's very co-opted. We know they don't have to publish adverse results, and they manipulate, they ghostwrite. There's a lot of problems with that, with money influencing the science. And with wheat, I think it really, I just don't see that kind of bias coming up. It's pretty objective. But, you know, again, I'm shocked by what I found. I haven't really gone over the exact studies with you in detail, but if you really look at them, because I'm just showing you the quick summary, it's called, where it just interprets how much